Okay.
Flight. Hey, God, I beg, I'm not.
Hey guys, welcome to the DLS Communities bi-weekly meeting or session. Uh, Normally, the session is supposed to be hosted by Deborah, but it turns out that she's not feeling too well. Extending my condolences. So I'll be hosting the meeting for today. I am OBCK Treasure. I was part of the speakers for the previous meeting, and thank God I'm here too to host this one too. By the way, welcome to. So, for this particular session, we'll be talking about operating systems and what they entail. We'll be introducing operating system and several other stuffs. We have we have several guest speakers here, or rather, our co-coordinators here that will talk about other sections of this meeting. We have the likes of Mr. Elvis Aslem, who is a technical writer, and Miss Angel Ifichuku, who is also another technical writer, a wonderful technical writer too. So Mr. Elvis would start, then and Angel will continue, then I would wrap it up. So without any further extension, I would introduce Mr. Elvis to come and present to us what he has for us today. So Mr. Elvis, can you take up the mic? Hello, Mr. Elvis, can you hear me? Hello? Mr. Elvis, it seems like you're muted or something. Okay, since Mr. Elvis is not yet here, so we'll just discuss about operating systems as a whole. First, we want to know what an operating system is. An operating system is basically should I say, a collection of softwares, or rather, managing softwares that work together to make the hardware a functioning tool. That is my own definition. So operating systems are a very wonderful section of the whole computer system as a whole, and how it relates to DevOps. Understanding it makes us understand DevOps more. Now, our operating system can contain lots of application programs, like the ones that manages processes, the one that manages memory, the one that manages several sectors of the whole system. So firstly, now we all know that there are three most popular operating systems that we know about. We know about the Mac OS, we know about the Windows, which is one of the most popular OS that we have. We know about the Linux OS. So most people like to use Windows, most people like to use Mac OS, most people like to use Linux. The developers mostly like Linux OS. Okay. Seems like Elvis is ready. So Elvis, you can kick off if you can hear me. Okay, guys. Sorry about that. It seems like Mr. Elvis is trying to fix his mic. So it seems like he has been trying to say something, but some things are just they're disrupting the whole thing. So we'll still continue on our discussion about operating systems. So we have the likes of we were discussing before. We have the likes of the Mac OS, the Windows, and the Linux OS. Most DevOps engineers love Linux OS. Like the like the OS of the server now. Why developers like using the Mac OS to build applications because it's easy and it's very close to the Linux OS. So we're just talking about the Linux OS now. So for this now, we'll just dive into types of operating systems. So we have several types of operating systems, which include the single taxing and the multi-taxing operating system, the single and the multi-user operating system, the distributed operating system, the embedded operating system, the real-time operating system, and many others. They have plenty of them. So each of these operating systems are there they are created due to the hardware that are available for utilization. Like now, if you have a very powerful system, you don't need to stress yourself. You can use a multi-taxing operating system on it. And an example of a multi-tax operating system is the Unix and the Linux operating system. We are all the Microsoft system, which includes the 32 bit and the 64-bit operating system, and the Mac OS too. Mac OS 2 is also part of the multi-taxing operating systems. So the single taxing operating system can only run on one program at a time, as the name implies, while the multi-taxing operating system allows more than one program to run concurrently. Okay, this is achieved by time sharing, where the available processor time is divided into multiple processes. These processes are each interrupted repeatedly in time slices by task scheduling subsystems of the operating system. What I'm basically saying is that the operating system breaks down the task it has. The multi-taxing operating system breaks down the tasks you have into chunks of tasks, and like into chunks of tasks based on time. They call it time slices. So as in actuality, it doesn't actually run it. It doesn't actually multitask. What it does is that it just simply insert as it has broken into slices of taxes. It can just simply be putting them, be running each of those slices as it comes. And the one that's already available just continues to run it and be going on and on. That is how basically it is. So that's how the multi-tax operating system work. Then we'll talk about the single tax operating system. That one is just running one process at a time. It doesn't run more than one process. After the process is done, it's over. The whole system has completed the stuff. So we'll talk about the single or multi-user operating systems. Hmm. Well, all of us are familiar with the multi-user operating system. They're just basically operating systems that can allow more than one user to be using it. Like one of our users registered for it. Some of these multi-operating systems have the ability to do what we call disk fragmentation, or rather shared this in memory. They can easily just chunk up a part of the memory and use it for a particular user and share the other memory too for another user, such a way that these two users don't have like their data don't get mixed up. So another example of a multi-user operating system is also the Windows. You can create plenty user profiles on the Windows. You can have the guests, you can have your own profile, you can have your brother's profile, and still control them easily. We have the Linux too. The Linux too allows you to create multiple users too. So although most of the Linux systems are just terminal, they just have only terminal, so you have to use command line to operate them. Yeah. Why the single user operating system just provides the option of one single user. I think one of the examples of single user operating system are like those ones that are in those olden days phones, like all these Nokia phones. Then you can only just have one screen and one screen alone. You don't have any. You cannot create multiple accounts. The current Android system now, the current Android phones that can allow you to create multiple user profiles. Now you can have the second space. Second space, like you can use to hide things like your banking app and all other stuff there. I'm using that one and this other one together. So in that Android device now, there is no like, you don't have the issue of something like the data being mixed up or something. Everything is isolated. Yes, the keyword I'm looking for is isolation. So the multi-user operating system can create this kind of isolation, memory isolation for each of those users. So for as a single user now, you can now like you have only one memory allocation to you. You can use it and do every other stuff you want to do, but you can't create multiple user. Then we move on to the distributed. Distributed operating system manages a group of distinct networked computers and makes them appear as a single computer as all computations are distributed, that is divided amongst constituent computers. What this basically means is that you can have several computers everywhere around the world, yet you still have one big, massive operating system managing everything, coordinating requests and resources. And a very big example is, I think I should say, the internet. The internet is a one giant big operating system. So it coordinates resources, distributes them perfectly in a way that is harmonious. Then we talk about the embedded ones. The embedded operating systems that are designed and used on embedded computer systems. They are designed to operate on small machines with less autonomy. Examples are the PDA. They are very compact and extremely efficient by design and are able to operate with limited amount of resources. An example is the Windows CE and the Mixin 3. So we'll talk about the real-time operating system. The real-time operating system is an operating system that guarantees a process or an event that may be multi-task or single task. So it runs the events. It processes the events in real time, whether the events are multi-task event or single task events. Okay, it seems like Mr. Elvis is available now, so I'll be giving him the mic to present what he has for you today. Trust me, he has something very special ready for you guys today. So let me add him to the stream.
Hi guys, can you hear me now? Hello guys. Hello. Can
Yeah, we can
anyone?
hear you now. We can hear you
Yeah, we
now.
can hear
Go on.
you.
Jesus, finally. God. I'm so sorry about that. Yeah, I'll just dive in, straight to what I'm supposed to talk about. Sorry once again. So yeah, system administration. Yeah, I'm going to be speaking of system administration in Linux. So quickly, what is system administration in Linux? This is basically the process of setting up, configuring and managing a computer system in a Linux environment. So what does this mean, right? It basically just means you having a a user account, in your Linux system, in Linux environment. It could be any of the flavors of Linux. Basically, it could be Ubuntu, um, you know, CentOS or Fedora. You get my point, right? So just basically setting up any of those virtualizations and platform, and then using that to take reports, perform backups, update configuration files and documentation. and also performing recovery actions, in case of when there are emergencies. What's if you are a Linux administrator, what should you know, right? This is like a profession on its own in the field of DevOps, right? So there are people who study Linux, Linux and its um, surrounding systems, right? Just to be administrators, right? Just to monitor and basically take care of um, these environments. So the job of a Linux administrator is to manage the operations of a computer system, right? Like maintaining, enhancing, creating user accounts, reports, and taking backups. Basically, you are um, at your system 247, right? You are not allowed an off time, right? You should be around your system, monitoring for all of these things, right? And and you can't do this thing without using Linux tools and command line interface tools. I'll mention some of those are, subsequently. Linux administrators are also expected to handle large Linux files, right? Manage the root user, have a working knowledge of bash commands, and an ability to manage users. Yeah, we know commands are like a million and one, right? But it is your responsibility to know most of these commands, right? However you want to document them, it's entirely up to you. But as the administrator, you should have like already sorry like a full background, a good background, sorry, a good background, knowledge wise now of Linux and how it works, right? And knowing what most of these commands, what they are, when to use them for, and their usefulness. It will help you a lot as an administrator in the Linux environment. So what are the duties of a Linux system administrator? Basically maintenance of the environment. Really, that is like your primary role as an administrator. Maintenance, troubleshooting, and providing support when there is an issue with the Linux servers. This is why I said, you are sitting down around in front of your system 24/7, just to take care of problems that might come up, because they will come up at different points, right? Also analysis of log files, right? Say when your system crashes, for instance. So give me a minute, just a minute. I need to, right? Say when your system crashes, for instance, right? You would instantly go to your logs and then check for like what happened, right? But if you are not a Linux administrator, you won't know what you're looking for there. And it's not just Linux administrators really, but especially for the Linux administrator, in charge of that system, in charge of that environment, analysis of log files is part of your job description. Support of LAN and web applications, creation of operational and project specific solutions for the organization, and the ability to proactively figure out ways to enforce strong security practices and increase scalability in your Linux environment. Um, Next slide. The skills every Linux system administrator should have. As a Linux system administrator, what should you learn? Like, what skills should you have? Right, you should, for one, have good management of user accounts, basically. So this what I mean here, or what is meant here, is this is your primary responsibility, basically, right? It is one of the responsibilities that it is basically handed down to like junior level Linux systems administrator, right? So say interns now, right? And it is not because they are trying to be like insultive to them, but it is because this particular role, managing user accounts, is very time consuming, right? And to be and it is considered, because of this, it is considered as a lower level activity, right? Compared to like other functions that are important, like backup and recovery, for instance, or troubleshooting, or maybe patching, for example. So this is given mainly to like junior level administrators to be in charge of. All right. So the next skill we should have is like is network traffic packet capture. Okay, what does this mean? This is basically capturing, interpreting, and analyzing network traffic. Okay, it is a very important skill because of its very many security implications to the data that is received from it. Right, network traffic can alert you to multiple attacks, or multiple different types of attacks in real time. And if you have if you know how to maneuver this, you can troubleshoot you know these attacks and other network problems. All right. um the VI editor, I know most of us have heard about VI editor, Vim, and there's the other one that has kissed my mind, but like Vim is very popular, right? um so Vim is like it is the editor of choice for like a lot of Linux system administrators, and not just system administrators, like for DevOps engineers as a bunch, as a whole. Vim is like the go-to editor of choice. It is then it's it is the go-to editor of choice for like a number of reasons, right? For one, it is very easy to use. The interface is like straightforward. It is not difficult to understand. It is instantly it is installed by default, right? So say you have Ubuntu, for instance, or even CentOS, because yeah, it comes by default as the editor of choice. So this is like, as a result of this, people just pick up on it immediately, right? And every system administrator should know how to use this, basically, right? Because of its popularity. um and yeah, it's been around for like I don't know if my statistics is correct now, but I think more than 40 years now. The VI editor, the VI test editor, has been around. And yeah, you should have a good knowledge about how to use it. So backup and restore, um backup, restore, and other disaster recovery activities per se are essential for you as a Linux system administrator, right? You have to know how to back up and restore files for your users, right? It is like a given. If you or a member of your team performs backup, you need to audit these backups, periodically, by restoring a few files to check your backup and restore process, right? So this is another knowledge you should have. The hardware setup and troubleshooting is another skill you should have. Every system administrator needs to know how to set up, maintain and troubleshoot their troubleshoot hardware systems, right? It's not just about software. You also know how. You also need to know how to go move around hardware. Um, you need to know how to deal with the failures that comes with hardware sometimes, right? Like for instance, disks, right? Memories, ports, for instance. And okay, there's also the rare CPU problems, that come. So you need to know how to do this. You are an engineer, you know, in the full sense of the word, as a Linux administrator too, because this is something that you should know how to take charge of. Um, Even if your infrastructure, right, even if your system is entirely hosted, or it is an entirely cloud based, right, you should be familiar with the other, or the different hardware, the underlying hardwares, and their configurations. Network routers and firewalls, the last skill here that you should have. um, you know, it is important that a little something about your networks, about the workings or the inner workings of your network, right? So you have to like get familiar with your networks routers, your firewalls. It is which is why, as a DevOps engineer, it is advised that networking is complicated, right? It looks complicated, but to understand it looks like this is further maths or something. But like you should try to like grasp the concepts basically that guides how networking works and how firewalls works. You would have to like examine your system configurations at some point as an administrator yourself. You examine these configurations to decide if they are consistent with Linux system, the best practices, security best practices. And this means that you should be running host based firewalls. It is this is like very in depth, but the main point of this is that you should have good knowledge about how network work, how firewalls work, and how routers basically how they all work. All right. So here are some Linux commands for system administrators. Right. So there is the PS. The PS is basically, give me a minute. Ooh, give me a minute, please. So basically, these are like because I've wasted too much time trying to like get on to speak. So let me make out time for the other speakers. So I'm just going to like watch this part. These are like Linux commands. These are not all. These are some. They are a lot, and this is just for Linux, right? They are like okay for every tool, right, that you use as a DevOps engineer. There are like different commands that you have to know, right, to be able to maneuver those tools. For a tool like Docker, for example, tools like Jenkins, Kubernetes, they have their commands that you have to know. These are like these ones there that you see on the screen are just some of the ones you should know, and I would suggest you look them up, right? Know what they do really. And yeah, I've come to like the end of my short presentation. I have to apologize again, right? I had technical issues, and I am really sorry about that. I hope we have a great rest of the session, all right? Thank you, guys.
Uh, okay, thank you very much, Mr. Elvis. That was a very lovely session. I learned a lot about Linux operating systems and system administration as a whole. I hope you guys learned too. Anyways, without much further ado, I would like to welcome Miss Angel to come and give us our wonderful presentation. Miss Angel, can you hear me? Miss Angel, you have the floor. Come on, wow us now. Okay, so while we wait for Miss Angel to be ready, let's continue our discussion about operating systems. Yes. Um, when I was younger, I used to play with the Windows XP. I know one of you guys must have known about the Windows XP. That's a very lovely operating system. I used to like it a lot. Like we had this very wonderful game. Then I think it was Solitary. I loved that game. It was wonderful. Yeah, the Windows XP operating system was like the benchmarks of operating system then for us here in Nigeria. I don't know about the stuff. Okay, Miss Angel, are you ready? As we were saying, so Miss Angel, are you ready?
Yes, I am. I am. Can you hear me?
Okay. Yes, I can hear you. Okay, so I'll continue my story later. So, Miss Angel, you can have the floor.
Yeah, thank you very much, Elvis. Oh, sorry, Treasure. Good evening, everyone, and
Good
welcome to
evening.
another bi-weekly and welcome to another session of our bi-weekly session of DevOps Learning Space. Today, I'm going to be talking about process and memory management in DevOps. And I'm very sure at the end of this session, you guys are going to have proper understanding of what process and memory management is in DevOps, and also know the importance of it in DevOps. Okay, so I'll just quickly present my slides. I'm coming. Okay. Sorry, please. So sorry for the delay. No. Yeah, can you see my screen now?
Yes, Miss Angel, your slide is
We
live.
can.
You can see it.
It's live, right? Okay. So today we're going to be learning about process and memory management. What is process management? So process management is basically the set of activities and practices used to manage and scale the execution of computer programs. And it involves the coordinating and controlling of the allocation of resources and memory space to ensure the programs run effectively and efficiently without interfering with each other. So, process management is more of like the step process. In fact, hearing the word process will already tell you this is like a step by step stuff. So, this is the step by step activities or procedures taken to manage and scale the execution of computer programs. And process management involves a lot of tools in DevOps, which are used to maximize the effectiveness of the software development cycles. And they involve a certain level of skill to be able to carry out the operations. There are various importance of process management in DevOps, and here are the four main ones I listed. Yeah. Can you guys hear me?
Yeah, we can. We can.
Okay. So um the importance of process management in DevOps are streamlining software development. In DevOps, sorry, process management helps in streamlining the software development lifecycle by identifying inefficiencies and bottlenecks. That is, say, identifying problems and identifying problems and providing solutions to the irregular management of processes in DevOps. Sorry, I'm kind of having a problem with my network and it's like logging me out. So they are streamlining the. So please, you guys should give me minutes. I'm like having problems with my network.
Minute to set up our stuff. Let us continue my discussion about the operating system I used when I was still a young boy. Well, yes, as I was saying, I got to use Windows XP. It was lovely. I used to remember I used operating system for quite a while because it was the operating system that was used by my 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 school, my primary school. So the operating system that was used there then. So after a while, the system I used to like play with got bad. So uh, they got another system for us. It was a Windows 98. Well, just imagine going from Windows XP to Windows. It's like going from 14 to an iPhone 6. Then the process management of the gets it freezes if overloaded with processes and many other stuffs. What I'm just trying to demonstrate, I'm just trying to tell you like this, I'm just trying to show you the upgrade, the level of upgrade they had from that Windows 98 to Windows XP. The Windows 98 wasn't that good at process management at all. Then the Windows XP was great. Was great. After a while, we stopped using the Windows 98 because of the system we're using got bad again. The monitor had color issues and we had to leave it. So later on, we got to use the Windows 7 when it came out. The Windows 7 was a wonderful system. As one of the best features I loved about the Windows 7 was that arrow effects that it had when you have something like a transparent, actually it was translucent tab. It was looking very good. It had this nice aesthetics. The process management was lovely. It was top notch. It got to an extent that I was even think I even felt like the Windows 7 was way better than the Windows 8 that came out later on that year. I loved the Windows 7. It was good. It ran background tasks perfectly. It freezes sometimes too, but that's when I'm overloading it, obviously. I used to always like do plenty work on other softwares too. So back then, I loved monitoring the tax manager. By the way, every Windows operating system comes with a tax manager that can use to see the processes that are running on the operating system. Can find out that by clicking on the Windows icon, then searching for tax manager, you'll see it there. I don't know the shortcut. You can check the shortcut later. So after a while of using Windows 7, by the way, I loved it. It was wonderful. It freezes less. Although, and the last Windows 7 I used had the blue screen of death. It's and I experienced that too. It crashed and all my data was lost. So after then, I had to upgrade the system to the my PC to a Windows 8. Windows 8 was cool. I loved the tile system they used. The processes were better, but still were comparable to Windows 7. That is process management. With Windows 7, it had nice graphics updates. I don't know what it is with software, but it was seemingly a little bit better. I used it for a while with no issues. Then I went on with the Windows 8.1. Okay, it seems like Miss Angel ready. Miss Angel, are you ready?
Yeah.
Are you ready for us?
Yes, I am.
Okay.
Yes.
So I'll
So
continue my story later.
back to the importance of process management in DevOps. So streamlining software development in DevOps involves the identifying of inefficiencies and bottlenecks in process management and implementing measures to optimize the flow of work. So by continuously monitoring and refining processes, DevOps team can reduce the time it takes to develop, test, and deploy software, and also increase the speed of delivery and improve the overall quality of the product. Improved collaboration. DevOps process management emphasizes on the importance of collaboration and connections teams and stakeholders and encourages communication and feedback throughout the whole development process. This helps to ensure that everyone involved in the process, in the project, is aligned and is carried along with the goals and objectives, and issues are identified and as early as possible. Consistent quality. DevOps process management helps also to ensure that software releases are consistent in terms of quality and functionality, thereby helping in the automating testing and quality control processes, and also using standardized development methodologies. DevOps teams also can avoid and also reduce the risk of errors and defects in software releases, improving customer satisfaction and reducing costs associated with fixing issues. Continuous improvement. DevOps DevOps process management is also focused on constantly monitoring and analyzing the performance metrics in identified areas for improvement, driven decision making. DevOps teams can quickly adapt to changing requirements, and continuously improving their processes and delivering better products and services to customers. There are different aspects of process management in DevOps, and I have listed a few here, and I'm going to be talking on them. Sorry. Process management typically involves, the aspect of process management in DevOps typically involves different types of activities. And here are the following activities. Process scheduling. This involves the this involves the determining of which processes should run at a given time and place based on factors such as process priorities and CPU usage. The operating system uses scheduling algorithms to manage the CPU's resources and allocate them to processes in a way that optimizes performance. Process synchronization. This involves the coordinating and the interaction between the concurrent processes to ensure that they do not interfere with each other or cause conflicts. That is to say that when during process management in DevOps, when spaces and memories are being allocated, this particular aspect is going to help in ensuring that there are no interference in the allocation of memory space. This also includes synchronization mechanisms such as monitors and message passing to ensure that processes access shared resources in a mutually exclusive and safe manner. Communication. This involves the proper communication between the channels and protocols that enable processes to send and receive messages, signals, and data. This includes using techniques such as shared memory space, pipes, sockets, and remote procedures calls to enable processes to exchange information and coordinate their activities. Overall, process management is a very critical aspect of modern operating systems, enabling them to execute multiple tasks and concurrently and efficiently. By managing the allocation of resources and coordinating the interaction between processes, process management, and memory management, it helps to ensure that computer systems operate reliably and efficiently, and that users can perform their tasks effectively. Memory management in DevOps. Memory management in DevOps refers to the set of practices and techniques used to manage the allocation and usage of memory in software systems. This also involves programs having access to memory needed to run effectively and also prevent conflicts and errors that can occur when multiple programs share the same memory space. Memory management is very important in DevOps in order to ensure that operating systems operate efficiently and reliably. There are different there are four types of there are four importance of memory management that I listed here, and I'm going to be talking more on them. So I'm going to be talking about improved system of performance. Efficient memory management helps to ensure that software systems run smoothly and with optimal use of available resources. Proper memory allocation and deallocation can help to prevent memory leaks and other issues that can cause slowdowns or crashes, improving system performance and stability. Enhanced security. The effective memory management system is critical for ensuring that security and integrity of software systems are protected and has access controls and encryptions, which helps to prevent unauthorized access and protect sensitive data from theft or corruption. Better resource utilization. DevOps team can optimize the use of memory management techniques to to help in resource utilizations, enabling them to do more with less. By allocating memories more efficiently and preventing resources conflicts, teams can maximize the use of available resources by reducing costs and improving efficiency. Improved customer experience. The effective the effective memory management can help to ensure that software systems are responsive and reliable, providing a better customer experience. By preventing memory-related errors and crashes, DevOps teams can deliver high-end quality products and services that can meet customer expectations and needs and drive business successes. Memory management in modern operating systems. This is a critical component of the modern operating system, which needs to manage the allocation and usage of memory for multiple processes and applications simultaneously. There are some key features and techniques used in modern operating systems for memory management, and I have listed a few here. Virtual memory. This involves the use of virtual memory to allow each process to have its own address space. It enables processes to access memory that is not physically present by using disk space or an extension of RAM. Virtual memory also allows the operating system to protect processes from each other, preventing one process from accessing or modifying the memory of another. Memory paging. Paging is actually a technique used in virtual memory systems to divide memory into fixed size blocks called pages. When a process needs to access a particular page of memory, the operating system brings that page into physical memory from disk and maps it out into a virtual address space. Memory segmentation. This is another vital technique used in virtual memory systems to divide memory into logical segments based on the needs and wants of the process. Each segment may have its own set of permissions, and enables the operating system to protect memory from unauthorized access and foreign bodies. Memory allocation. This uses a variety of memory allocation techniques to allocate memory to processes and applications. And some common techniques of memory allocation includes the fixed partition allocation, the dynamic partition allocation, and the body allocation. Because of the little time I have, I might not be going deep into this, but I will share a resource on where you can get and read more on memory management and process management in DevOps. Thank you very much, and I hope to see you guys next time. Bye for now.
Okay, thank you. And I've learned a lot about memory management, process management, and several others more. Anyways, it seems we've come to the end of our bi-weekly meeting. You don't have any other stuff to add again. I will continue my story at the next session. So you have to stay tuned. You have to be live to hear the rest of the story. Thank you very much, Elvis. Thank you very much, Angel, and thank you very much to the host that I wasn't able to be here due to her health issues. We pray for your steady recovery. We love you very much, and we need you back. Thank you. Thank you also for tuning in to the operating system session. Everybody that is listening to this session, thank you, Mr. Ikechukwu. Thank you, Mr. David. Thank you, Mr. Martins. And also thank me too, the temporary hosts. Thank you very much, guys. Have a wonderful weekday. Good night.